Students, this is a Similarity Preview Notes. The Similarity Preview Notes, the introduction to our new chapter. By the end of this video, you need to be comfortable with these words: ratio, proportion, similar, scale factor, extremes, and means. Should also have colors handy. We're going to talk about a ratio. A ratio is a comparison of two numbers by division. A comparison of two numbers by division. We can use words, like the word two. We can use a colon, a fraction, or even a decimal. Let me show you a common ratio. For example, you can have 3 to 4, or you can express it like this: 3 to 4, using a colon, or as a fraction, 3 to 4, or 3 over 4. And to get to a decimal, just think in terms of money. 3/4 of a dollar, 0.75. So this is really important that you understand this. All fractions are ratios, because that's by far the most common expression you're going to be using in this unit is fractions. Definition of a proportion. A proportion is an equation of ratios. So a fraction, a ratio, can be a fraction. So that by itself is a ratio. But if I do this, that is a proportion. So when you have a proportion, the product of the means equals the product of the extremes. Say this out loud with me. In a proportion, the product of the means equals the product of the extremes. That doesn't make any sense to you at the moment, but let me give you an example. Let's say you have a ratio here is 2 to 3. And we have 8 and 12. Let's order these terms from least to greatest. Our least term is 2. Then we have 3, 8, and 12. The means are the middle numbers, 3 and 24. Let's write those here. 3 and 8, excuse me. That's your means. Let's multiply them. 3 times 8, 24. Now the very beginning and the very end numbers, circle those. Those are called the extremes. So let's do 2 times 12, which of course is 24. Aha! Notice the product of the means equals the product of the extremes. This happens when your proportions are what's called a true proportion. You guys actually already know this under a different terminology. I'd like you to put an arrow and connect the means. Now put an arrow and connect the extremes. Basically, we cross-multiplied. I have good news for you. In this unit, this entire unit, what I'm doing right now, if you have a proportion and you can consistently and accurately cross-multiply, that's about 80% of this chapter. Boils down to that. Now, we have to be able to comfortable to use ratios. So we're going to do a few problems using ratios here. It says Shauna drove 245 miles, and she used 8.2 gallons of gas. At the same rate, that means there's an equal sign there somewhere. If she drove 416 miles, how many gallons of gas will she need? So we can make a proportion. These are ratios. We have miles over gallons of gas. And we're given one ratio already, 245 miles for every 8.2 gallons equals 416 miles and unknown gallons. Do not grab your calculator yet. At this point, you must at least show your cross multiplication. So like this and like this. So now we have 245 times x equals 416 times 8.2. Not yet. Don't touch that calculator yet. You will get to in a moment. Don't touch your calculator until your variable is completely by itself. So x is not yet by itself. So we have one more step here. 245. Now our variable is by itself. We have x equals 416 times 8.2 divided by 245. Now you may grab your calculator when x is by itself. So we have 416 times 8.2 equals, divided by 245 equals, says round to the nearest tenth, we need 13.9 gallons of gas. 13.9 gallons of gas to go 416 miles. Number 2, we're going to watch for keywords and we're going to make an equation and then solve for the proportion. 3 to an unknown, that's x, is, that's an equal sign, 18 to 24. Now remember that 2 is a type of ratio, which means we can turn these into fractions. We have an equal sign. So we have 3 to an unknown is as 18 to 24. Now we're going to cross multiply. We have 3 times 24, and we equals 18 times x. Do not grab a calculator yet. We want to get x by itself. So we're going to divide by 18. Guess what? You still don't need to grab a calculator because remember the key to multiplying sometimes is not multiplying, it's simplifying. So we can do this. Watch. 3 and 18. 3 goes into 18 6 times. You're not done. Circle 24 and 6. 6 goes into 24 4 times. So x equals 4. Number 3, you want to watch out for a change in units here. Watch out for a change in units. You want to write in simple form fractions. So I wanted to be a simplified and fraction. So here we have 44 to 2, and we just simply go 2 goes into that, 22 over 1. Now that looks like what I just did was correct, but it's wrong. I did that on purpose. I want you to be very careful in this unit when you are given Units, centimeters, meters, inches, feet, etc. You must pay attention to them. If all you do is look at numbers, you're going to make a mistake. What I just wrote, what would be a mistake? We have 44 centimeters to 2 meters. Before we could reduce this fraction, we have to get them into the same unit. I'm going to get both of them into centimeters. So 44 centimeters doesn't change. We want to change 2 meters into centimeters. Centi. Same prefix as century or cents in a dollar. Wait about 10 seconds here. See if you can't convert that by yourself. There's 100 centimeters in a meter, so this 2 meters becomes 200 centimeters. Now that our units are the same, we want to reduce our fraction. So I'm going to have 44 and 200, and I want to divide them both by the same, so I'm going to divide by 4. And I get 11 over 50. And you ask yourself, can you divide it by anything else? Both of them? The answer is no. So this is the correct equation, or excuse me, the correct reduced fraction, not 22 over 1. So watch out for units. Now, for these two, I'm going to set the timer for 2 minutes. I want you to attempt to do these two problems completely on your own in 2 minutes. Go. Alrighty, let's take a look and see how you did. So we have here 2 supplementary angles. You should pause right there and write the definition. They sum 180. Have a ratio of 2 to 3, find the measure of the angles. So I'm going to draw a linear pair because that's the easiest way to get supplementary angles. We know whatever they measure, they have to add up to 180. They have a ratio of 3 to 2. So what we honestly have is we have a 3 of something and a 2 of something. So we have 3 of something plus 2 of something equals 180. And our something is 36. So 2 times 36, that means that is going to be 72 degrees. 3 times 36 is 108. Now let's just check. 108 plus 72, 1. It does add up to 180. That's our first check because they have to be supplementary. Now we ask ourselves, does it have a ratio of 3 to 2? Well, 36 goes in there 3 times. 36 goes in there twice. 3 to 2 ratio. So our angle measures there would be 108 and 72. Okay, solve for the variable. This is basic cross multiplication skills. So I want to see, never distribute in your head. You should have done 5, y minus 3 parentheses equals 8 parentheses y plus 6. Draw your distributive lines. Next line reads, 5y minus 15 equals 8y plus 48. Minus 5y both sides. I'm going to bring it over here. I have negative 15 equals 3y plus 48. Here I'm going to go minus 48. And I get negative 63 equals 3y. I divide by 3. And I get y equals negative 21. Okay, so working with ratios and proportion is really critical in this unit because everything's going to boil down to ratios and proportions. These shirts, small, medium, and large Valley Christian High School t-shirts, have the same shape but a different size. We would say these shirts are similar. That is the slang definition. Same shape, different size. That is the definition of something that is similar. Say it with me out loud. Same shape, but different size. That's the definition of similar. And the symbol for similar looks like this. Looks like a little Spanish tilde sign. So we say these shirts are similar. They have the same shape, but they're just a different size. Now we're going to get into the technical definition of similarity. So shapes which are similar have these two qualities. They have congruent angles and side ratios which are equal. Congruent angles, side ratios equal. Let me show you what I mean. In the shapes here on the left, let's check if we first have congruent angles. So that shows that they're congruent. Here they show they're congruent. Here matches and here matches. So the first one, congruent angles, check. We have congruent angles. Now we're going to see, are the ratios equal here? So we have 3 sets. Circle the 4 and circle the 8. Draw an arrow. 4 goes into 8 twice. So this reduces to a 1 to 2 ratio. Let's check another set. Ready? Circle the 6. Find its match, which is 12. 6 goes into 12 twice. So again, we have a 1 to 2 ratio. Let's check another one. Circle 2.8 and 5.6. If you can't do the math in your head, you can just do this. 5.6, let's see if it divides by 2.8 twice, and it does. So we have here a 1 to 2 ratio. So we have a 1 to 2 ratio each and every time. 1 to 2, 1 to 2, 1 to 2. So we would say these two shapes here are similar. They have the same shape but a different size. Scale factor is when we compare the ratio, when shapes are similar, scale factor is the ratio of the sides. So scale factor, we're going to express it one of two ways. Side-to-side comparison or side-to-side. So it's just important that you match up the sides correctly. So for example, this 15 does not match with 9. It's not in the same position as 9. It matches the same position as 3. So if these were similar, I simply would take my 15 to 3 ratio and I would reduce it. 3 goes into 15 5 times. So I have a 5 to 1. This would be considered my scale factor, the lowest reduced ratio of the sides. So we're going to find the scale factor of the similar shapes below. Unless I tell you which direction to go, just go left to right if possible. So circle 18, let's find its match, which is 24, 8, 24. For good measure, let's check our other one, 6 and 18. Now reduce them both. 8 goes into 24 3 times, so this is a 1 to 3 ratio. Six goes into 18 3 times. It's also a 1 to 3 ratio. So we would say your scale factor for these two similar shapes is a 1 to 3 ratio. That would be your scale factor. Now we're going to do some examples together. So in number 1, we're going to determine if the shapes are similar. Remember SCARE. So similarity means CA, congruent angles. And then we have RE, which is ratios are equal. So CA means congruent angles, RE means ratios equal. Let's check to see if it's the case. Here we have matching angles, matching angles, matching angles, matching angles. So yes, the angles are congruent. So that's our first one. It's a yes. Now let's see if our ratios are equal. Let's just circle 12 and its match is 4. Circle 18 and its match is 6. Let's circle 6.9 and its match is 2.3. Let's check our ratios. 4 goes into 12 3 times, so this reduces to a 3 to 1 ratio. 6 goes into 18 3 times, so this reduces to a 3 to 1 ratio. 2.3 times 3 does equal 6.9. So this is a 3 to 1 ratio. So yes, our ratios are equal. So we would say these shapes must be similar. There's our similarity sign. Number 2, since ratios are equal, when things are similar and you have equal ratios, then the sides are what are called proportional. Now quickly, make a little baby definition of proportional so you don't get lost as to what that word means. Proportional means you can do one of these guys. 2 equal ratios. That's a proportion. We're going to use the proportions to solve for unknown lengths. The image below are similar. Find the missing side. There's a couple ways to do this. So they are similar. I'm going to put the little similarity sign between them. First off, we're going to find our scale factor. So we find any 2 sides that are in the same position that have nothing but numbers. And that's going to be 9 and 6. So I'm going to go 9 and 6. Now to get my scale factor, you reduce as far as you can. We're going to divide both of them by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. So we would say 3 to 2 is the scale factor. Now, if that's your scale factor, we could actually use this to solve a proportion. Ready? So we're going to go circle 9, draw an arrow to 6. 9 over 6 equals 21, circle, draw an arrow to unknown. And then you solve for x. Or, since we already reduced 9 over 6, we could also use the scale factor. 3 to 2 equals 21 over unknown. Either would work. So from here we cross multiply. So I have 9x equals 6 times 21. The key to multiplying is not multiplying. It's simplifying. So rather than getting your calculator out and doing 6 times 21, why don't you do this instead? Let's get x by itself. So I'm going to divide by 9. So I end up with x equals 6 times 21 divided by 9. So now let's reduce as far as we can without a calculator. So I know 3 goes into both 6 and 9, so I'm going to cross these out. 3 goes in here twice. 3 goes in there 3 times. Now I'm going to circle the 21 and the 3 because those reduce. 3 goes into 21 7 times. So now you just do 2 times 7. The answer is 14. Okay, 3. We're going to do an example here. It says find the variable in the side length knowing the shapes are similar. So I know the shapes are similar, which means scare. They are similar, so I know they have congruent angles and ratios equal, which means at some point I'm going to do that. So let's look at what we have. We have a scale factor of A going to B. Circle A. Draw a little arrow to B. Now come up here, establish your direction. A going to B, and my ratio is 2 to 3. Please physically draw the letters and the direction that they force you to go. So in this case, we're going to go from left to right. So I'm going to put a little A and B here because that's the direction I want to go. So A over B. A is 2, B is 3. Now I match up. My A is 14 and my B is 7 plus X. From here we cross multiply and we're going to take it from there. 2 parentheses, 7 plus x equals 3 times 14. You distribute. We have 14 plus 2x equals 42. So we're going to minus 14. And I get 28. And now we divide by 2. And we get x equals 14. Let's actually see if that worked. X equals 14. So this is 14, and if that's 14, that makes this side 21. Let's check it. 14 over 21. Let's see if we can't reduce both of these. So divide by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Aha! There is our 2 to 3 ratio. And we know our x is correct. Our x is 14. So what I want you to do is give these problems a try. Problem 1, 2, and 3 on your own. I'm going to set the clock for 5 minutes. I want you to attempt to do these on your own for the next 5 minutes and then check your work. So we're going for 5 this time. Okay, students, let's check your work here. So taking a look here, it says, given the shapes are similar, find the scale factor of the smaller to the larger. So that's the direction we're going to go. We're going to go from smaller to larger. So we start just by writing small to large. Now the only thing you have to watch out for is to make sure you actually match the size. So this 21 here matches to the 49. So we're going to go small to large, 21 to 49. I see 7 goes in both, so 7 goes in here 3 times, 7 goes in here 7 times. So my scale factor for the first one was 3 to 7. Now I come over here and it says to go from small to large, so I write small to large. Now I want to match any two sides. So I'm going to do 72 to 84. Why not 84 to 72? Because it says small to large. So small is 72, large is 84. I'm going to see if these guys are divisible by something. Let's see. We know they're divisible both by 4. Four goes in there once, as this is 18. And 4 goes in there 21 times. And we see that they're both still divisible by 3. And we get 6 to 7. So our scale factor here was 6 to 7. It says the following images are similar, solve for the unknown. Okay, there's a little trick to this. It says the scale factor from A to B, but we go A to B. So that's going to be 3 to 7. So I'm going to go A to B, 3 to 7 equals 36 over 3x plus 27. Now I cross multiply. 3 times 3x plus 27 equals 7 times 36. I'm going to distribute. This is going to be 9x, and then 3 times 27 is 81. And then I have to do 7 times 36. 2, carry the 4, that's 21, plus 4 is 25, so I have 252. So I minus 81 both sides, end up with 9x equals 252 minus 81. It's 171 divided by 9. Nine goes in there once, with 8 left over, 19. So x equals 19. That's for 2. Let's check out number 3 here. So you determine if the following are similar, we're using scale. So we check for angles, congruent angles, and we see that they're equal already. So now we check for ratios being equal. So we have to match them up. So we have 4 to 6, and that's 2 goes in there twice, and then 2 goes in there 3 times. That's a 2 to 3 ratio. Now we have 6 to 12. 6 goes in there twice, and that's a 1 to 2 ratio. And this last one, that is a 1 to, it's not 3, 7.7 divided by 2.6. It's approximately a 1 to 2.9 ratio, so the ratios do not equal here. So we would say these are not similar. Let's check the one on the right. 12 to 8 4 goes in there 3 times, 4 goes in there twice. It's a 3 to 2 ratio. Let's check this out. 24 to 16, 8 goes in there 3 times. 8 goes in there twice. That's a 3 to 2 ratio. Let's check this last one out. We want to see if that's a 3 to 2 ratio. So I take 18.3. I'm going to divide by 12.2, and I get 1.5, which is a 3 to 2 ratio. Remember, 3 to 2, 2 goes in there once with 1 left over, so 3 to 2 ratio is 1.5. So this second one is yes, they are similar. First one was no, right one was yes. Go back, review these items prior to class.